Good morning, this is your stats sensei, Mr. Spensei, and we are going to run a hypothesis test in a scenario. The next scenario will be a confidence interval, but we're going to go all the way through it, to the entire process. So the average maximal volume in oxygen uptake of all adults is 36.7. So they're telling me this is an average, and this is of all adults. So this is probably going to be the population mean, but we'll keep going. A physician believes that a jogger's maximal volume of oxygen uptake is greater. Ooh, that's probably an important word than that of the average of all adults. And there are more than 10,000 joggers, so we have a huge population. A sample of 35. Okay, so this is our sample size. So we're going to note that down because we're probably going to use that later. So we know our sample size is 35, has a mean of 43.6. So this is our sample mean, which is X bar. And a standard deviation of 6. So our sample has a standard deviation of 6. Now this is really important that that's our sample because it's being the sample standard deviation is what makes this a T. Is there enough evidence to support the physician's claim at the significance level of 0.01? So we have an alpha level of 0.01. So what's our parameter? Well, we're interested in a maximal oxygen uptake. So, but we're not interested in everybody. We're only interested in joggers. So let mu equal the maximal volume oxygen uptake of joggers. We're not interested in all adults. We're just interested in joggers. Our hypothesis. Well, our hypothesis is the original claim. Well, of all adults is 36.7. So that's the status quo that we're testing against. So the mu is 36.7. But we want to see if the joggers is greater than 36.7. And I got that greater than from right here where they told us it was greater. Our formula, because this is a hypothesis test, it's T equals X bar minus mu S over the square root of N. And what makes this a T distribution is the fact that we're using the sample, sample standard deviation. The conditions. Well, the conditions for a hypothesis test are random sample. And they told us it was a random sample of, in this case, 36, and that was given. Then they asked us, we need to check for the N is less than 10%. So our sample size, well, it's not 36, it's 35, excuse me. N is 35. So we're going to make that 35 and we're going to multiply it by 10, and we always multiply it by 10, and that equals 350, and that happens to be less than 10,000. All right, so that's taken care of. We can check both of those off. And normality, well, we don't know if oxygen uptake is normal or not, but we have a sample size of 35, so N equals 35, and that's greater than 30. So it's normal. Actually, it's approximately normal by CLT, by central limit theorem. All right, if I'm drawing a picture, here's what I have. I have a population mean, and the population mean is 36.7. And by the way, I should have labeled these. Can't just put a number out there. 36.7 milliliters per kg. Milliliters per kg. So here we have, this is what we expect. But we have our joggers are sitting here at 43.6. So there we go. So our mean was 36.7. Our X bar is 43.6. Our standard deviation is 6, and our sample size was 35. And based on our alternative and what way we shaded, we know we wanted greater than. So the probability that T is greater than our sample mean of 43.6 minus 36.7 divided by and a sample size of 35. All right, so let's go ahead and run this. We're going to go to stat test, t-test, population mean of 36.7, sample mean of 43.6, standard deviation of 6, sample size of 35, and we hit calculate, and we get a pretty large t statistic of 6.8034. So the probability that t is greater than 6.8034, this inequality and this one need to match, and they all need to match the alternative. And we got a super small p-value. Now it looks like it's greater than 1. You cannot have a probability greater than 1. This is in scientific notation. In fact, I need 7 zeros, so 0.0000, but we just stop at 4. All right, and I'll put an approximately 0 because it's not really 0. So our p-value is approximately 0. Our alpha, they said, is 0.01. So 0.0100. Well, this is definitely less. And when our p-value is less than our alpha, we reject the null. Our p-value is, and it's not really 0, so we're going to say it's approximately 0. We reject the null. There is enough, there is sufficient evidence at alpha equal 0.01 to suggest that we need to redefine our parameter, and our parameter was the maximal volume of oxygen uptake of joggers, that the maximal volume oxygen uptake of joggers is, well, what does our alternative say? Is less than 36.7 milligrams per kilogram. Is less than 36.7 milligrams per kilogram. And I'm not even sure what that means. All right. But I know that we have enough evidence to say, hey, you know what? Joggers, oh, excuse me, I wrote less than. That's not less than. That's a greater than. That's a big mistake. That's a big mistake. Got to fix that. Is greater than 36.7 milligrams per kilogram, because that's a greater than symbol. All right. So we basically said, yeah, joggers apparently have a higher maximal oxygen uptake than the rest of the population. I appreciate you watching. Hope to see you on the next one. Thank you.